Welcome to qnawire.
So now we're going to work on problem 41 from chapter 5. In this problem, we're asked to draw a Lewis structure for the acetate ion, including all resonance structures, and to indicate which atoms will have a formal charge. So the acetate ion is usually written as CH3COO minus. So if we were to add up all these electrons here, we have 8 from carbon atoms, 12 from oxygen, and 3 from hydrogen, which makes 23 electrons. But then we consider that we have 1 for the negative charge, so we have 24 electrons total. So as we start to draw these Lewis structures here, we're given a little bit of a clue about the structure based on how it's written. So we have a carbon bound to 3 hydrogen atoms, which is bound to the next carbon, and then we have 2 oxygen atoms, like this. So we have our skeleton down based on the structure, the name that we're given. So here we've included 6 bonds, so that's 12 electrons. So we need to assign lone pairs to our outer elements first, outer atoms. So we can put the additional 12 electrons around oxygen atoms. However, what we see here is that carbon, the second carbon, is deficient of electrons. It only has 6. So instead of having 2 electrons on one of these, three lone pairs on one of the oxygen atoms, we're going to put a double bond here. So now every atom has an octet. And then the only atom which shows a formal charge, because the hydrogens are all 0. The carbon in this first carbon, or both carbons, form 4 bonds, so they have 0 formal charge. So we have the 2 oxygens. This oxygen here is not going to have a formal charge because it's 6 minus 4 lone pairs plus 2 bonds. However, this one here will be -1 because it's 6 minus 7. So this is a correct structure. However, the double bond doesn't have to form with the oxygen on top. It could also form with the oxygen that is on the right. So instead of that, we have a double bond on the right with 2 lone pairs here and 3 around the top. And in this case, the formal charge would be on the top atom. And both of these structures give us an overall charge of -1, which we see is correct.